Let's observe another pattern that shows up through multiplication that we can use to identify the factors of perfect squares, or in this case, the difference of perfect squares. So when I multiply the binomials a plus b times a minus b, that works out to a squared minus b squared. There's no middle term here because when I multiply the outer terms, I have minus ab. When I multiply the inner terms, I have plus ab, and those cancel out. The only result is a squared minus b squared. Sometimes we'll use this relationship moving forwards to help us multiply two factors. Sometimes we'll use this relationship moving backwards to help us factor. Remember, factoring is the reverse direction of multiplication. So here's how this works in factoring. When I see two terms subtracted from each other and they're both perfect squares, I can take the square roots to find a and b, and then I can apply this formula to find the factors. The factors are a plus b times a minus b. So I look for this whenever I have two terms, they're subtracted from each other, and they're both perfect squares. Factor 16y squared minus 9. Those are both perfect squares. The square root of this is 4y. The square root of this is 3. Notice that I took the square root of both the number and the variable. They both have to be perfect squares. The whole term must be a perfect square. Since these are both perfect squares, they fit the difference of squares formula, and my factors are 4y plus 3, 4y minus 3. That's it. You can confirm through multiplication. If you multiply those binomial factors together, they should give you this result in the end. Second, factor x squared minus 25y squared. Well, those are both perfect squares. The square root of x squared is x. The square root of 25y squared is 5y. I'm not going to worry about a negative sign when I'm taking this square root because the negative sign is built in, or the subtraction is built into this formula. So we say the factors are x plus 5y, x minus 5y. Third, let's factor 64x squared plus 25. Now, this has a square root. The square root of 64x squared is 8x. The square root of 25 is 5, but these are not subtracted from each other. These are being added together. This is actually a prime polynomial. And whenever we see the sum of perfect squares, a squared plus b squared, we can always conclude that it is prime. There is no way to factor the sum of perfect squares. So this is a very helpful formula, but only when we're working with the difference of perfect squares.